Example 5.
Bases on a baseball diamond. Now, I myself am not a particular fan of the old national pastime.
Are you telling me about baseball?
Yeah, that's the national pastime, Mrs. Stevenson. Did you know that?
Sorta-ish.
Yeah.
Okay, so...
Play ball!
Why don't you talk
All right,
about
so,
the problem? I'll get a nice little picture.
Bases on a baseball diamond are 90 feet apart. Now, that's a known fact. And the front edge of the pitcher's rubber is 60.5 feet from the back corner of home plate. Now, there have been some rule changes in baseball, and I'm not up to speed on much of that because I don't really follow it. So that may be a little off now, but I digress. Find the distance from the center of the front edge of the pitcher's rubber to the far corner of first base. Now, the pitcher's rubber is that little strip of rubber that's staked into the pitcher's mouth.
I drew it in the middle, but it's the middle-ish. Like, we can't take that to be, and that's part of what we end up finding in this problem, I think.
Yeah, it's part of the whole process. Right. So we want to find the distance from the center of the front edge of this pitcher's rubber to the far corner of first base.
So from here to here?
Yeah, basically from there to the corner of that.
I mean, it's the end of this
Well, yeah, because
line.
the bases should be on the inside, so that's okay.
I was a little
that's all right.
flamboyant with my drawing.
It's a beautiful drawing.
Thanks.
But now we do know how far,
Bases are 90 feet apart.
Right.
Okay.
Yeah, we got that. Okay, let's label that real quick.
Well, can I draw this? I think this
front
is
edge. Okay, front edge. Yeah, front edge of pitcher's rubber to home plate is 60.5 feet.
Now I'm going to switch back to my. Okay, so the bases are 90 feet apart. So that's these two situations right here.
Yep.
Well, all four of those.
Yeah,
actually,
we just basically need those two probably,
so
maybe
this is
three.
60.5.
Right.
Okay, and that's what we know. Right there. We know two sides.
Right. So what we need to find is that distance there from the pitching mound, the pitcher's rubber over to first base. So that guy right. We need that. We need that guy. Now,
we know two sides.
Cool thing. This is a baseball diamond.
Okay.
Which means that if you draw a straight line from the pitcher's rubber over home plate, we just cut our diamond, that angle there, into two equal pieces. A diamond is a square on its side.
Okay. Yeah.
So we've got us
a 45-degree angle right here.
Bam! Hot dog and popcorn coming right up for K-Steve.
And that's because we don't know that this direction, that this way, we are not cutting anything in half. But we do know that this direction, we're cutting in half.
Right.
And so whatever that angle is, well, and specifically the reason this works is because it's a baseball diamond, but this is really a rhombus. And I don't know technically if diamonds are actually necessarily always rhombuses.
You know what? You're correct, probably.
But
a rhombus with all four sides the same.
Right. And it may even be a square. I don't know, but it kind of looks catty-wonka. If that's a real
catty-wonka. It's like Patty Wonka. So anyway, this looks like a law of cosines.
Side angle side.
Hey,
we want to figure out this right here. And so here's how this works is that's the side we're trying to find.
Oh, it just equals it already.
And, okay, if you need to label the triangle with A, B, and C for the angles and little a, B, and C, go for it and use one of those things.
Knock your socks off.
But here's what we need to know. The side we're solving for on this side and that angle go together.
Right.
So because these are across from each other, this is going to work out.
It's got to be 45 on that angle.
Yeah. So x squared equals one of the sides
plus the other one squared
plus the other one
minus 2 times both.
Right. There's like a really clear pattern here that we're trying to
times the cosine of the angle across.
So cosine 45
look at that.
Then we just type all that in, square root it.
Jeez. Let me just... I get 63.7.
63.7 after the square root?
Yeah, after the whole square rooting process takes place.
That's the answer. This is
now remember, when you take the square root of both sides, you get plus and minus of that, but we just need the plus part.
Because we're talking about distance.
Because we're talking about distance.
Positive.
That is correct.
So that's all we've got for you for 5.6. Happy 5.6ing.
Quit touching that thing.
I don't know how that happened.
Jeez.